stuff. And then we have the Earth interacting with the 4 kilograms. Do I know amounts here? Yeah, 2 kilograms. That's 20 newtons. 3 kilograms. 4 kilograms, 40 newtons. All right. Any other interactions going on here? The pusher. Okay. So I've got a pusher. What? Why wouldn't I? The pusher is touching just the 2. All right. Do I know that amount? 18 newtons. Man, this problem seems pretty straightforward. So far, we know a lot of these things. All right. Anything else we need to have here in our system schema? So interaction with what object? I mean, it doesn't really say like table or anything. It just says surface. I'm going to call it surface. Surface. Smoosh poosh, because 2 is touching the surface. Smoosh poosh, because 3 kilograms is touching the surface. And 4 kilograms is touching the surface. Amounts? 20, 30, 40. Are we on an incline? Is there evidence of any other weirdness happening in the vertical direction? So I think for that reason, we're safe to say that we know this is going to be 20 newtons. This is going to be 30 newtons. Hang in there, Blake. 40 newtons. All right. You just yawned. All right. So sounded like you. All right. So here's my system schema. And this is one of the things people were talking about. We don't know what these smoosh pooshes are yet. 18, you say. Might be wrong. So for that reason, I'm going to advise not pretending like that's a thing right now. I know this is 18 because it tells me, but then it gets kind of complex in there, okay? So some classes we went about this with the Harding smooshing a classmate problem. But I want to explore a technique here, and a couple people mentioned this. They said, is it helpful to think about it as one thing? So what I'm going to do is I'm going to throw a blanket over these. And I'm covering them with the blanket. Okay, they're underneath the blanket. And to the outside world, all that we know is there's what under there? 2 kilograms, 3 kilograms, 4 kilograms. There's 9 kilograms of stuff. We don't know if it's 9 1-kilogram things or 1 9-kilogram things or a 2, a 3, and a 4 kilogram thing. We just know there's 9 kilograms under the blanket. The blanket is called the system boundary. Okay? Say it kind of hoity-toity like that. System boundary. Like your top and bottom lips move when you say boundary. Boundary. Okay. So now I'm going to draw what I call a system schema. That seems redundant, but I've got the system, and the system interacts with the pusher to the tune of 18 newtons of smoosh poosh. Now I've got 3 lines there. That would be like 3 interactions, but if I'm just treating it like one thing, I'm just going to consider it one interaction with the surface. Smoosh poosh. It's how much? 20, 30, 40, 90 total newtons of interaction with the surface. Okay? And then with the earth, gravity, and again, there are 3 lines here, 20, 30, 40 newtons, but since I'm just thinking of it as one system, I'm going to think of this as one interaction and it's 90 newtons. And suddenly this gets a little bit clearer because if I do a free body diagram for the system, now I've got 90 newtons down. This is FG system, comma, Earth. I've got 90 newtons up. This is F smoosh poosh system, comma, surface, and then I've got 18 newtons, F smoosh poosh, system, comma, pusher. These forces balanced or unbalanced? Ooh, let's do a little fad here and see how unbalanced they be. 90, 18, 90. Are they unbalanced? How unbalanced are they? So here's my 18 Newton FU. How do I know it's an FU? It's big, fat, and stripy. And it begins at the beginning and it ends at the ending. Okay, 18 Newton FU. So acceleration equals FU over M, 18 newtons. But what am I going to divide that by? 9 kilograms. Who's got a calculator? Wait, don't tell me. 2 meters per second squared is the acceleration. Now, consider this. These things are touching. So if I give them a push and they're touching, what's the acceleration of this? What's the acceleration of this? What's the acceleration of this? So now you know the acceleration for everything. This is the benefit of system analysis. So now, hey, shoosh. So now when I go in to draw free body diagrams for these things separately, 2 kilogram, 3 kilogram, 4 kilogram. This is usually the last thing we come up with, but here it's going to be the first thing we come up with. What's the FU going to need to be for the 4 kilogram to have an acceleration of 2 meters per second squared? 8. Question was, what is the FU going to need to be here for this thing to have an acceleration of 2 meters per second squared? This is West High, right?
How many?
I mean,
8.
Okay. 3 kilogram mass. What are we going to need the FU to be to have an acceleration of 2 meters per second squared? 2 kilogram mass. What do we need the FU to be to have an acceleration of 2 meters per second squared? So, knowing what your FU needs to be, knowing what your system schema looks like, and now we're going to want to peel back this blanket over here, and I'm going to wish I hadn't highlighted all that. How do you erase highlighter? Dude, I've done a lot since I did that. Can I draw it in white? Let's just try her.
Oh no. Please put in another line. This was a good plan. How long did you done it?
Well, you can see through the highlighter. All right, so kind of you can see through the highlighter. Of these 3 objects, which one is the least complex? Or actually, let's talk about that the opposite way first. You're nihilists. Which one of these is the worst? 3. It's got 2 unknowns here. So which is the least worst?
Not 4.
Maybe the 2, because you know 3 of the things. Okay. So there's only 1 unknown, or maybe the 4, because you know 2 of the things. There's only 1 unknown. I advise going after one of those first. But then what I'll be waiting for is in the pair deck. Could you be a deer and in the pair deck, can you share your free body diagram for 3? Whoops, that's not how that works.
How are you doing?
All right, so get back together on your whiteboard, get after it. You know the FUs need to be. So start thinking about how the forces go together.
You think I'm going to take You say problem. I say slightly better. Oh yeah, B minus. It was because I got a It was just like, overall, and that was basically it. And I was like, it was mostly because of the fan. So, honestly, I was
Gang, we got about 15 minutes. I really need you to tidy this up in the next 10 so we got time to debrief. That's a diagram for box 3. Middle. 3 kilogram box. Oh. I can see why you would draw that for box 3.
Wait, are we doing it on the board?
Yeah, you need to think about it on the board first.
It's 2 front, 3 back. Wait. Yeah. I teach. Front force. There would.
Yes.
I was like, wait a minute.
So again, I'm looking for you to sort this all out on the whiteboard and show me what you got by eventually putting your free body diagram for a 3 kilogram box in the pair deck. Better be a free body diagram that leads to an acceleration of 2 meters per second squared.
And back is 2.
And then if you.
Oh, no.
I think we're 4.
That doesn't make sense. 6.
Like that one pops up.
I'm just saying what we know
That's 2.
and what you're probably wrong.
Well, okay. No, but the object in front of it is 4 kilograms. Let's push it back 4 kilograms. Which is 40. Let's push it back 4 kilograms. And it has to be 6 newtons displacement, therefore 100 newtons. Wait, is that right? I can't think. Okay. Then, stopping it.
Okay, so my thing is 30 newtons, 30 units. You know it's
4 kilograms back. How much? So, how many units?
right. And then 16.
What? How many newtons? What's that?
2 kilograms pushing it.
18 newtons.
Oh, okay. Yeah. That is big. And then to be 12 back because it's 6 newtons of pounds for
20 plus 18, 58.
I think, and then you just hit my I'm trusting you.
That's how it sounds, but I'm going to So, box is 4 kilograms, 4 newtons. So it's going to want to like push back.
It comes from the acceleration.
Right. No. We're talking about box 3, or the 3 kilograms. So this is the 3 kilogram box. It's pushing because it's 3 kilogram boxes, right? So it's stopping it by 4 kilograms.
So I feel like it's just pushing
No, that's
like
Wait.
Pusher's pushing this.
Okay, we can find it more first. So,
The 2 kilogram box pushing that.
time 2 and 4. What is Wait, why is there a 4?
But I could switch down. I believe that it's not gonna happen.
Okay. Give me that now, and then this.
But it's not pushing or interacting.
2 kilograms.
I've been enlightened.
What?
How's it probably be?
Oh my
Does that mean that it rises on the box by? What's the next one? It goes like this, right?
Apparently.
1, 2, 3.
It's slowing down.
We're not giving us the answer. Cameron, you can get out. Cameron, get out. Okay.
Alright, so, hey, I'm asking for your free-body diagram for object free, so can I point a couple of things out? There are text tools that you can use to label things. We need number values on these arrows, and FU is not a force, don't put it in a free-body diagram, okay?
That's fine, sorry, put that one up. That one's really good. I have full label. That's mine. That's not mine.
Hey, can you stop with the nonsense for a second and tune in? All right, looking at what I'm seeing in here, a lot of you just went right to the 3 kilogram box and didn't worry about the other things. My advice was to either start by thinking about the 2 kilogram box or the 4 kilogram box. So please, please, please go back and make sure you've done that, because I don't see a correct drawing in here yet. And there are a lot of diagrams in here. You tried to shortchange yourself and it shows. I did, bro.
And we don't know what to see.
There literally is not a correct free-body diagram in the house.
By
I have 30, 10,
we don't know. We're not trying to buy it. We know the we know the damages, we know the accelerator. So you try
Oh, yeah.
This pushes back with the exact go forward. It's accelerating, it's not balanced.
I don't know if that looks too bad.
in this case, yeah.
Actually,
Wait, you better make sure that all your diagrams work in concert with each other.
okay, so that is just basically like the
Squared on sorry.
What's 2 9 of 18? 2 9 of 18?
I mean, I get it. I know.
Let me explain this.
What?
Do you expect us to throw butter?
Lots. It doesn't make sense.
Well,
Not consistent with the other diagrams.
Give me like stack
18 minus 4. That's all it is. Yeah. So here's what I'll take. This so we can divide the minus 18. So we also have so they each get a different amount, right? Yeah. So this would be 4. So this I didn't understand how it is. So this last the force of balance is 4 is equal to So this has to be that means that force point that way. But it's accelerating. So it has to go right. Yeah, that's right. So we add 4, 2.
It's just underestimating.
Wait.
So it's a fatal error.
All right, we're not getting there. So let's chat about it.
21.
Or at least it's not making its way over into the pair deck. My personal preference is to go after the weakest ones first. And so to me, that's the 4 kilogram. Okay? So if you look at the 4 kilogram here, I'm going after this one because I already know, hey, Shoosh would be great. I already know 2 of the forces. I know 40 newtons down. That's FG 4, Earth. I know 40 newtons up. That's FSP 4, surface. I need to have an FU of, it's a 4 kilogram box. 4 kilograms, 2 meters per second squared. I need an FU of 8 newtons. The oh, is this frozen?
No.
Oh, okay. So the only interaction I have available is this smoosh poosh from box 3. If you look at box 3 is over here. Smoosh pooshes are drawn perpendicular to the surface at the point of contact. They're drawn away from the dealer. So I'm going to come down here and I'm going to draw an arrow this way. It's 8 newtons. It is FSP 4, 3. If I fad these arrows, I go 40 up. I go 8 to the right. I go 40 down. Are these forces balanced? How unbalanced are they? Boom. Okay. So I'm gooch. So now I slide back up to my system schema, and this is why I advise making it quantitative. I can declare this interaction to be 8 newtons. So my only unknown is over here. Let's dive at the 2 kilogram quick. 2 kilogram box. I know that I have 20 newtons down, 20 newtons up. This is FG 2, Earth. This is F smoosh poosh 2, floor. I have 2 other interactions. One of those is a smoosh poosh from the poosher. That's 18 newtons, FSP 2, poosh. The only unknown is the interaction with 3. That's a smoosh poosh called 2, 3. I don't know what it is. I do know that my FU needs to be how big for this thing? So if I go 20 up, 18 to the right, 20 down, how big does this force need to be so that I get the FU, the proper size of 6 newtons? This has got to be 14. So now I can go into my system schema. Hey, now I go into the system schema and I know this interaction is 14. This one is 8. So now when I go to draw 3, 30 down, 30 up, 14 to the right, 8 to the left. Now when I fad these arrows, 30 up, 14, 30 down, 8. What do I get for an FU? 6. 6 divided by 3 kilograms, 2 meters per second squared. Checks out. Okay? So notice, hey, pause. Notice I've got 8 newtons, 8 newtons. Notice I've got 14 newtons, 14 newtons. What's up with that? Forces come in pairs. There you go. All right. So take a picture of the work you got on your board if you like. This is in the notes.
Lily and I already got the message in the main office.
Go ahead and clean up the whiteboard after you take a picture of it.
The main office. We're on that this.
Everything. No. You got it. You did the math right. You just didn't draw it right. For science, it's not hard. Okay.
I'll take the marker. So give me the eraser. You're gonna do that.
Hey, Dr. Katz.
Put it away. Just please.
Wow, you're trash.
Yeah.
Andrew, give me your hand.
Yeah, we're not in my.
This back on the way down.
I don't know what you're talking about.
Okay, yeah.
No, not the paradise lights.
The window?
Right there.
No.
Do you know how to get to that?
Yeah.
Your canvas?
Alright.
Aye. There we go.
Okay, so this diagram, the FAD, the first FAD.
Over here?
Yeah, can you go scroll down?
Sure.
The math sort of tripped me up. All right, so
Sure.
okay, so if the FU is 6 newtons,
Yeah, not here. Oh, did I write 6?
it really
Oh, yeah, that should have tripped you up. Because what should it be?
2. It should be 2 kilograms, which is times 2, which is 4.
This should be 4.
Okay, I just
Gracias. Good thing I still have the screencast going. Good eye.